All right, so area of trapezoids is a little bit more involved than triangles or the other quadrilaterals that we've done so far. And that's because the trapezoid has a pair of bases. So if you look at the top, we have a little intro here. It says most gliders use the straight wing model to achieve the greatest speed and lift. The wings of a glider can also make a polygon. Below is an aerial view of a simple glider. The lower glider has two wings in the shape of a trapezoid. So this is one wing off the side of the glider. You'll notice that two of the sides have arrowheads on them because they are parallel. Those are your two bases. Now, the bases of trapezoids always have to be the one pair of parallel sides, and the height is going to connect them. Now, on this particular trapezoid, the height happens to be one of the sides. So what we would do is we would call this base 1 and base 2, and it doesn't matter which one is base 1 and base 2. And then the side that connects them, or the segment that connects them at the 90-degree angle, is the height. So trapezoid has exactly one pair of opposite parallel sides. Below that, you can see three examples of trapezoids. Now, the parallel sides, which have that arrowhead, those are always going to be your bases, so base 1 and base 2, and the height will always connect them at a right angle. On this one, the height happens to go down the middle with the dashed segment. On the second one, the height happens to be horizontal, right, side to side with that dashed segment, because the parallel bases on this one are on the left and the right, like they were on the glider up above. So those are probably the most common ways that a trapezoid could look, but you can also have what's called a right trapezoid. And a right trapezoid has the one pair of parallel sides that are your bases, and the height is actually a side making the right angles to connect them. So on the trapezoid on the far right, why is the bottom side considered the height? It connects the two parallel bases at a right angle. So we want you to notice that it's possible for the side or a side to be the height. It's also possible that the height has to be one of those dashed segments through the middle. So let's do two sample trapezoid area questions. So this is one side of a glider. So on the glider, you have the wing. Now the wing has to have the parallel sides, which we saw up at the beginning. And in this case, the parallel sides are the 11 and the 5. And then you've got the height, which is at a right angle connecting the parallel sides. So when we go to find the area, you'll see that there is an area formula over here for a trapezoid. Inside the parentheses, you have to add the bases together, and it's 1/2 times the sum of the two bases and then times the height. Now on a triangle, it was just 1/2 times base times height because the triangle only has one base. But on the trapezoid, we're finding the average of the two bases, which is why we have to add them together. So if I write area equals 1/2 base 1 plus base 2 times the height, I can take those numbers off of my diagram. My base 1 and my base 2 are the blue parallel sides. So I would have area, which is what I'm looking for, 1/2. In the parentheses, I'm going to add the bases together, 11 plus 5. And then the height, which is the pink right angle side that connects them, the height in this case is 38 feet. So parentheses first, 1/2, inside the parentheses, 11 plus 5 is 16, and then times the height, 38. Now this is just a series of multiplication. You can do it in any order you want. I would do the 1/2 times 16 just because I know off the top of my head that that's 8. And it still needs to be multiplied by the 38 because I have not done that yet. So 38 times 8, 24, 25, 26, 27, 28, 29, 30. So it's 304. So the area of the glider wing is 304 feet squared. So the glider wing has an area of 304 feet squared. Area, remember, is units squared. Now, I also have down here at the bottom a little picture of the part that's called the elevator. This is the part of the glider that either, tips it up or tips it down, so you can sort of control where the glider is going. This is also in the shape of a trapezoid. You'll notice that it still has the two parallel bases, left and right. And then you've got the height, which is no longer a side. It has that dashed segment up the middle that makes a right angle. So we're still going to do the same process. I did notice that one of my bases is a decimal. So this time I'm going to say area equals 1/2 as a decimal, base 1 plus base 2 times the height. I'm going to fill in all the parts that I know. I'm looking for the area, so I don't know that, 0.5. My bases, the blue parallel sides, are 4.5 and 3. And then the height, this dashed segment connecting them at a right angle, is 8. Again, I have to do what's in the parentheses first. So adding the 4.5 and the 3 gives me 7.5. And this is a series of multiplication that I can do in any order. So I'm going to do the 1/2 times the 8 because that's going to save me some effort. I know half of 8 is 4. So 4 times 7.5 means I have to do the least amount of computation possible. So over here on the side, I'll do 7.5 times 4, 20, 28, 29, 30. Bring in my decimal point and I get 30. So the area is 30 feet squared. So I can say the elevator, which is that back flap, not an up and down elevator in a building. The elevator has an area of 30 feet squared. And I have found the area of 2 different trapezoids.